Let's take another problem on vectors. This is exercise 5.4. We are continuing the same exercise. Question number 16. Find the direction ratios of a vector perpendicular to the lines whose direction ratios are first. Okay, so in this question, basically they are giving us two lines with the direction ratios as. So there are two lines. There are two lines with the direction ratios. One of the line has the direction ratio -2, 1, -1, and the other has -3, -4, and 1. So there are two lines basically. So here, say this is one line. This is one line which has the DRS -2, 1, -1. And then we have another line. We have another line. Say this is another line. And the DRS of this line is -3, -4, and 1. What we have to do? We have to find, you can check. See, what does that say? What does the question say? They say, find the direction ratios of a vector perpendicular to lines whose DRS are this and this. So you have to find the direction ratios of a vector which is perpendicular to these two lines. Okay. Now see, when it comes to a vector perpendicular to these two lines, the vector could be either this way. See, the vector could be this way. Now here you see that this vector is perpendicular to both the lines. The vector could be this way. It is perpendicular to both the lines. You can check. You can check here. The vector is perpendicular to this line. And it is also perpendicular to this line. It is also perpendicular to this line. It is perpendicular to both the lines. This vector. So either it could be this way or it could be another vector which is just in the opposite direction of the one that I drew. Okay, it could be this vector. Now even this vector, you see that it is perpendicular to both the lines. It is perpendicular to both the lines. So I have to find either this vector or this vector. So how do I find these vectors? See, what I will do is, as we have done earlier, when we learned DRS, if you remember, I had written a very important point and I said that you have to learn by heart this point under points to be remembered. If you remember what we had written, when we know, I will use the black ink, when we know DRS of a line, then we can write vector, we can write a vector parallel to that line. Okay, so this point to be remembered. So here you have a line, say this is line L1, this is line L1, and this one is line L2. So what you have? You have here, so I can say let A bar I can say let A bar be a vector, which is let A bar be a vector, and that A bar I can write it as negative 2 I cap plus 1 j cap minus 1 k cap. What I'm writing? I'm writing A bar using the direction ratios. Okay, I'm writing A bar using the DRS of L1. A bar is parallel to L1. Okay. Similarly, what I can do is I can write vector B bar, and vector B bar I can write parallel to line L2, and you can check. See, this is how B bar is. So I can write B bar here. I can write B bar. And what's B bar? B bar is parallel to L2. So B bar can be written as minus 3 I cap minus 4 j cap plus k cap. After this, what I will do, I will find out B bar cross A bar. You can find out A bar cross B bar or B bar cross A bar. Either of them you can find out. Okay. If you find B bar cross A bar, then remember you will get this vector. Okay. By right-handed triplet rule, you know, if you are finding B bar cross A bar, then B bar cross A bar. So you are keeping your 4 fingers in the direction of B bar. You are keeping 4 fingers of your right hand in the direction of B bar. You bend those 4 fingers in the direction of A bar towards A bar. Then the thumb will give you the direction of B bar cross A bar. So you will get B bar cross A bar, and that B bar cross A bar is the required vector. This is B bar cross A bar. This vector is B bar cross A bar. Now B bar cross A bar is perpendicular to both the vectors, so automatically it is perpendicular to both the lines. Okay, you can find B bar cross A bar, or if you want, you can even find A bar cross B bar. Even A bar cross B bar will solve the purpose. How? See, A bar cross B bar is this way. Now A bar cross B bar will come in opposite direction of B bar cross A bar. Even this will do. Okay, so I will find out B bar cross A bar, and then I will only put a negative sign, because this A bar cross B bar is nothing but it is negative of this vector. Okay, rest all it is going to be same. So I will start writing the answer. See, how do I write the answer? I will write here. So the solution will start as follows. I will write let let the let the given two lines let the given two lines be L1 and L2 respectively. Let A bar be parallel. Let A bar be parallel to L1 and B bar be parallel to L2. Okay, therefore we can write what we can write. A bar equals to and B bar equals to. A bar is minus 2 I cap plus j cap minus k cap, and B bar is minus 3 I cap minus 4 j cap plus k cap 1 k cap. Okay, so I will find out B bar cross A bar. B bar cross A bar is, you can find whatever you want. You can find even A bar cross B bar. So I cap, J cap, K cap, and B bar cross A bar. So I will write the coefficient of B bar in the second row. -3, -4, 1, -2, 1, and -1. So here I'll get I cap, and I'll get here 4 minus 1 minus j cap. I'll get here 3 plus 2 plus k cap, and I will get here -3 minus 8 -3 minus 8. So this is 3 I cap minus 5 j cap, 3 I cap minus 5 j cap, and this is minus 11 k cap. So you got B bar cross A bar. And what is this B bar cross A bar? I will write here B bar cross A bar is a vector perpendicular to lines L1 and L2. Therefore, DRS of a vector perpendicular to given lines are, what are those DRS? See, the DRS you will write as 3 minus 5 and minus 11. 3 minus 5 minus 11 are 3 minus 5 minus 11. Or you can write -3, 5 and -3, 5 and 11. You can write these three numbers or these three numbers. These three numbers we got because of B bar cross A bar, and if I had found A bar cross B bar, I would have got these three numbers. So either of them are correct. You can write both or you can write any one. It is up to you. This is the final answer. So I solved 16th first for you. You all must try 16th second. 16th second. And remember, never write DRS of a line or a vector in a bracket. Please don't do this. Okay, if you are writing DRS of a line or a vector inside a bracket like this, it would seem as if you are writing coordinates of a point. So never ever do this. The DRS or DCS of a line are always written as three numbers separated by commas without bracket. So I solved first problem for you. This is very important problem. You will all solve the second problem. Okay, now there is one thing which we could add here in the question. Here I was asked to find out direction ratio of a vector perpendicular to the lines which had DRS as this 3 number and this 3 number. Suppose instead of asking about a vector, instead of asking DRS of a vector, they could have asked us to find the DCS of a vector perpendicular to these two lines. So in that case, what would you do? You will find DRS, and after DRS, from DRS, you will find DCS. The method to find DCS from DRS had already been given to you in earlier videos. Secondly, they could have asked us to find simply a vector. Instead of asking DRS of a vector perpendicular to these two lines, they could have simply said find a vector perpendicular to these two lines. In that case, the solution is same as what we did. And when they ask you find the unit vector perpendicular to these two lines, in that case, you will first find the way I found B bar cross A bar. You will find B bar cross A bar the way I found, and then after that you will divide B bar cross A bar by its own magnitude. So if you divide B bar cross A bar by its own magnitude, then you will get a unit vector in the direction of B bar cross A bar, and hence what you got is the unit vector perpendicular to given two lines. So you must solve the second question. I solved the first one for you. The second one you all must try. So here question is question number 18. If A1, 2, 3 and B4, 5, 6 are 2 points, then find the foot of the perpendicular from point B to the line joining origin and point A. So I join point A with the origin. I get line joining origin and A. This is the line here. You can check. This is line joining A with O, origin. And now from point B, I draw a perpendicular to this line. So the foot of the perpendicular is M, I assume. And I assume that the coordinates of MB, which is the foot of the perpendicular, XYZ. So now I have to find the value of XYZ. See, how do I solve this? For solving this, I'll be using, if you remember, a pointer I had given to you all. A very pointer means the point to be remembered. And what was that? If A is x1, y1, z1 and B is x2, y2, z2, x2, y2, z2, then DRS of AB, DRS of AB are x2 minus x1, y2 minus y1, z2 minus z1. I will use this pointer. And you know what I will do? I will find out DRS of BM. So here I start writing the answer and the solution starts from here. I'll have to draw the diagram, okay? So I write here. I draw the diagram because, see, this diagram is not necessary for exam as such, but we do it for our sake of our simplicity, you know, for our help. So here I write DRS of, I write here, DRS of BM, DRS of BM are, see what are DRS of BM? It is x minus 4, comma, y minus 5, comma, z minus 6. I got DRS of BM. Then I will find out DRS. I write here DRS of DRS of AO, DRS of AO. So DRS of AO are 1 minus 0. See, A coordinates I know and origin O I know. So 1 minus 0, that is 1. 2 minus 0, that is 2. And 3 minus 0, which is 3. So DRS of AOR 1, 2, 3. Now, students, see, this AO is perpendicular to BM. AO is perpendicular to BM. I write here AO. I write here AO is perpendicular to BM. Therefore, AO is perpendicular to BM. Therefore, what you can write, you know, students, if you have two lines, which are perpendicular to each other, then what will happen is the sum of products of corresponding DRS will be 0. This we have done earlier. Okay, if you want, I will once again write it. Okay, see here, if you have two lines, with the DRS, say you have two lines, okay, and they are perpendicular, DRS of this line is, say, DRS of, say, this is L1, this is L2. DRS of L1 are, say, A1, B1, C1, and DRS of L2 are, say, A2, B2, C2. And these two lines are perpendicular to each other. So what will happen? A1, A2 plus B1, B2 plus C1, C2 will be equal to 0. This is important point that you have to remember. So using this, what I will write here, see, x minus 4 into 1. So I will get here x minus 4 into 1 plus y minus 5 into 2, y minus 5 into 2 plus z minus 6 into 3, z minus 6 into 3 equal to 0. So this gets me x minus 4 plus 2y minus 10 plus 3z minus 18 equals to 0. So this gets me x plus 2y minus plus 3z, x plus 2y plus 3z, and here you get equals to 32. This is equation number 1 I got. Okay, minus 14 minus 18 is 30, negative 32 on the left hand side. I shift it to RHS, I get equal to 32. This is first equation I got. Okay, now after this, see what I do. The next I write is, I write the DRS of, see, I write the DRS of AM or MO, whichever, you know, AM or OM, whatever you want. So I write DRS of AM. Okay, I write DRS of AM R. What are DRS of AM? See, DRS of AM R, DRS of AM will be x minus 1, okay, comma, y minus 2 and z minus 3. So here I have x minus 1, comma, y minus 2, comma, z minus 3. These are DRS of AM. Okay, x minus 1, y minus 2, z minus 3. Now, if you remember, another very important point that we need to remember here was, if you have two lines which are collinear, okay, if you have two lines which are collinear, that is, they are parallel. So see here, L1 and L2, these two lines are parallel. Okay, DRS of L1, DRS of L1 are, suppose, A1 B1 C1 and A1 B1 C1, and DRS of L2 are A2 B2 C2. Now these two lines are parallel to each other. So what will happen? Since the lines are parallel, their DRS will be proportional. That is, A1 upon A2 will be equal to B1 upon B2 will be equal to C1 upon C2. See, these points I have already covered once. I am repeating these points once again for the purpose of understanding. So here what I have, A1 upon, when the two lines are parallel to each other, their DRS will be proportional. Okay, two lines are parallel or they are collinear. Okay, now here what I notice is line, look at line AO, look at line AO and line AM. Look at the line AO and line AM. They are coincident lines, so definitely they are parallel to each other. They are collinear with each other. So here I will write, since OA or AO, whatever you write, and AM are collinear lines, collinear, OA and AM are collinear, therefore their DRS will be proportional. Their DRS will be proportional. Now what does that mean? It means x minus 1 upon 1, x minus 1 upon 1 it means here x minus 1 upon 1 equals to y minus 2 upon 2, y minus 2 upon 2 equals to z minus 3 upon 3, and that is equal to lambda. I write here say means I suppose that these all are equal to lambda. Now what does that give me? Therefore, see, now each one of them is equal to lambda. That's why they all are equal to each other. So I get here x minus 1 upon 1 equals to lambda. This gives me x equals to lambda plus 1. Y minus 2 upon 2 equals to lambda. This gets me y equals to 2 lambda plus 2. And z minus 3 upon 3 equals to lambda. So this gets me z equals to 3 lambda plus 3. Now after having found x, y, z, I will substitute these values in this equation. See, I will substitute all these values. I will substitute the value of x, y, and z. See these values here which I obtained. I will substitute them in. I will substitute them. These three x, y, z. I will write. I will use them in one. I write here using x, y. I will write here using x, y, and z. X, y, and z in one. We get. So see what I get. I get here x plus 2y plus 3z is 32. X is lambda plus 1. So I get here lambda plus 1 plus 2y. 2 times 2 lambda plus 2 plus 3z plus 3z. So 3 times 3 lambda plus 3 equals to 32. So this gets me lambda plus 1 plus 4 lambda plus 4 plus 4 lambda plus 4 plus 9 lambda plus 9 equals to 32. So this gets me lambda plus 4 lambda 5, 14 lambda, and here 5 plus 9, 14. So 18. Okay, 32 minus 14 is 18. This gets me lambda equals to 18 upon 14, which is 9 upon 7. I got lambda as 9 upon 7. What I will do now? I will substitute lambda value in x, y, and z. I will substitute in x, y, and z. When I will do that, I will get the value of x, y, z. And remember, this x, y, z was nothing but, it was nothing but m. It was nothing but the coordinates of m. Okay, I hope you all have understood this. Refer to this solution once again, practice it. And remember, key for solving all these problems is the pointers which we have already discussed. Okay, so try remembering them. Now we will substitute lambda value in x, y, and z. Let us substitute lambda value in x, y, and z. Right here, using lambda in x, y, and z, we get what we will get. X equals to lambda plus 1. So 9 by 7 plus 1, that is 16 by 7. Y equals to 2 times lambda plus 2. So 2 into 9 by 7 plus 2, that is 18 by 7 plus 2. So y is 32 by 7. Okay, then z will be 3 lambda plus 3. So 3 times 9 by 7 plus 3, that is 27 by 7 plus 3, that is 48 by 7. We got z. So finally we got the coordinates of, point M. Therefore, M is 16 by 7, 32 by 7, and 48 by 7. The answer given in the textbook is wrong. That you must know. The answer given in the textbook for this question is wrong.